Recording's in progress. So today is February 7th. It is a review day. Our next, and we also have our Mars Lander lab today. On Monday, we will have exam 1, where we will spend the whole class period scribbling on circles. Yes, Logan. Lucian.
How many questions will we do?
There will be in the neighborhood, I think, somewhere around 40 to 45 on your bubble sheet will be filled in when you're done. I am talking into my T instead of the microphone. It feels kind of the same in your hand if you're not paying attention. You know, with this big microphone, I feel like I should be doing karaoke.
Hey, little sister, what have you done? Hey, little sister, who's your only one? Hey, little sister, shotgun, come on, it's a nice day to start again.
You like that? All right. All right, so before we dig into it, before I start talking at you, what questions do you all have? Yes, JJ. Can I go over anonymous inner classes again, please? Okay, so anonymous inner classes. You know what? I'm going to resize this a little bit because come on. All right. So less talking, please. So an anonymous inner class, right, looks like this. So I have keyword when I'm creating an anonymous inner class. The first thing is keyword new. The second thing is the name of the class or interface that I am overloading. The third thing is parentheses for the constructor call. The next thing is an open curly bracket and a closed curly bracket and a semicolon. Now, I put the open curly bracket and the closed curly bracket there because that's the whole implementation of the anonymous inner class. And in this case, runnable, our friend java.lang.runnable has a single method, public void run, which takes no arguments. So let's toss that in there. Now, if I want to, right, I can put an override on there, right? Okay, and then inside it, I can do something. So one of the things I can do is I can print something. All right, now if I compile and run this program, what happens? Nothing, right? Nothing. Because while I did actually put a print statement in there, it's a print statement inside a run method, which I never called. So let's fix that. Let's just have me call it. And I can say run.run. So now, not only am I calling it, but I am calling it twice. All right, so now I get hello on the screen twice. Now, the other thing that's important to know about anonymous inner classes is capture. Right. So it's one of the main reasons that it's convenient, in fact, is that we have capture. So I can say final string name equal Chris. And then I can say hello plus name. And this will work There should be a comma there, whatever. So this will work because I can access final variables from my context, right? Yes.
What's the reason for the override?
The override is just a check. It's the compiler is verifying that I am indeed overriding a method. If I could take it off and everything would be fine. But it's usually a good idea to put it there. Ty. It's the rules, right? Java has decided that it's too complex to manage what would happen if I tried to do that. So if I put an int here, and then I took this runnable object and I passed it to some other class, and now this int that I accessed has gone out of scope, how is the thing supposed to behave? It's too complicated, it's too weird. So they limit it to finals because that way it's easy to just make a copy of the thing and carry it around. Was there another question? Drew. I was going to say Drew. Drew, go ahead.
So you weren't able to access that final string name outside of.
No, I can access it outside of the run class, but the point is that I can access it inside. That's one of the benefits. If I were to create a whole new class from scratch, right, and put it in somewhere else, it wouldn't be able to access that final variable. All right, so that's one of the reasons to do it. What? If it's static, yes, it can. Right, so static variables are always accessible by everybody if they're public, right? So yes, JJ.
So Runnable is a class that's already in Java, right?
Yes.
So
It's an interface, actually.
So if you want to make anonymous inner class, you could do it with like a pre-made class that you already made yourself.
Yes, you can make an anonymous class out of anything that you could extend or implement. All right. Everybody get anonymous inner classes? Who has another question? Yes, Lucian. Yes, I can go over the, well, how about I think I've gone over the other quizzes, but I'll start with 3 at least. Okay, so let's take a look at quiz 3. Now, there was an error that somebody pointed out in quiz 3, and I'm sorry about this. And I think it's the reason why you all took so long to do it. Well, you'll see. I'm sorry about it, but I think, the damage is done. All right. So the first thing was true and false stuff, right? Primitive types should be compared with equals. No, it's objects, right? Primitive types cannot be used in lists. That's true, right? We have to use the wrapper types. You cannot instantiate a list. This is also true. List is an interface and we cannot instantiate interfaces. Only primitive types can be null. No, primitive types cannot be null. The objects can be null, but not primitive types. Static fields have 1 value per object. No, they just have 1 value period, right? 1 value per object is an instance field. Final arrays can be modified. True, right? We did this, right? The contents of the final arrays can be modified. And array lists are not of fixed length. That is also true, right? Array lists are growable. All objects can be assigned to object. This is true, right? Object is the superclass of all classes, right? So hopefully this part didn't give people trouble. If this gave you trouble, right, then you have to pay attention harder and study harder. I mean, because these are all things that were clearly stated. All right. So now we have this anatomy question, and I think it's very important. I didn't always ask these kinds of questions, but I realized that there are enough people who don't know what's going on, right? That And you can't afford to not know what's going on when you're programming. You can't afford to just sort of look at code and say, oh, I kind of know what this means. That's just no good. You'll never get anywhere if that's what you're doing. You have to understand what everything is in your program. And so I started asking these questions where you look at a piece of Java code and you identify the parts, right? So in this case, I've shown a slice of a class, right? And classes contain fields and methods. So it's clear that bar, for example, has to be a field, right? And it doesn't have static on there, so it's not a static field. It's just a regular field. It's an instance field. If you look at foo, right? Foo is an instance method. It's just, you know, that's what it is. It's a method sitting on the class. It does not have keyword static attached to it. System. Okay, so system, you should probably know by now that java.lang.system is a class that's part of the standard environment of Java. It's a built-in. But even if you didn't know that, it begins with a capital letter and there's no parentheses at the end of it, right? So if it begins with a capital letter, generally speaking, it should be a class. So you should assume, when you see this, that system is a class. The next thing is you see is .out. That .out, right, is it doesn't have parentheses, so it's not a method. It doesn't start with a capital letter, so it's not a class. Therefore, it is a static field, right? Because it's accessed directly from a class, and it's a static field. Okay, so out is a static field, and because out is a static field, printf should be an instance method, not a static method. Everybody puts static method. It's if the out weren't there, if I said system.println, right, then println would have to be a static method. But because the out is there, it's an instance method. Out is a static field, but printf is a static method, is an instance method. And then java.lang, Java and lang are both package name elements, right? We know because how? They're not uppercase, they're all lowercase, right? And then when we see that math in there, well, math is the thing that's got the uppercase. Therefore, math is a class, and indeed it is. Now, cosine is called directly from math. There isn't like some math.x.cosine, right? It's called directly from math. Therefore, it is a static method. It's all very simple if you just know those rules, right? Capital name for classes, lower name for other things, right? If it's in the beginning, like java.lang is, if it comes before the class, it's got to be a package. If it comes after the class and it doesn't have parentheses, it's a field. If it has parentheses, it's a method call. Does that all make sense? So whenever you look at a Java program, you can just parse it that way. You can just look at those things, and your brain should just tell you, yes, static field, instance method, whatever. You should be able to do that with no problem. Okay. And yes, you'll probably get another similar question on the test, but different. You know, I'll come up with some different way. The point isn't for you to memorize answers. The point is for you to memorize concepts, right? To learn concepts. Okay. Looking at the code snippet below, identify each line's function in the Java language. So line 0 would be a class declaration, right? And line 1 is a field declaration, right? We've just got an int n there. And line 2, as you can see, we've got a method declaration. Line 3, we have another method declaration. You might be tempted to say constructor, but this is for the people who haven't paid attention and don't know that a constructor doesn't have a return type. If it has a return type like void, it is not a constructor, it is a method. And, you know, I kind of feel like this should be an error, right? If you have a method that's the same name as the class and has a return type, it's hard for me to believe that isn't a programming error, but whatever, it's not. It's not flagged as such by the compiler anyway. So line 4, where is it? Oh, yes. Line 4 is an actual constructor, public bar int A, int B, right? That's tagged with line 4, and that is a constructor. Line 5 is a local variable or automatic variable declaration, right? And those declarations can include initialization. In this case, I have A times B. And then line 6 finally is a field assignment. So N is a field on my class, right? It is not a local variable, it is a field, and I am assigning to it. Does that all make sense? Anybody have a question? Yes, Drew.
I understand how to identify the constructor. I'm still confused on the constructor.
Okay, so the question is, what is the use of a constructor in the class? So a constructor is called when the class is being created to make sure its initial state is something that you want. Okay, so in an array list, right, I believe there's a constructor that takes an int. And what that will do is that will initialize the default physical size of the array for you. Not your logical size, mind you, but your physical size. And if you have a capital integer object, you can call the constructor to give it its value, right? You want to, the point of the constructor is to set the initial state of the object.
So when you call a class that has constructor,
Yes, a constructor always runs when you instantiate your class. If you have not defined a constructor, you get a null constructor that does nothing, and that's run. Okay, but there's always a constructor, and it always runs at the instantiation of your class. Good. Okay. All right. Yes. JJ.
Can you like show us an example of an interface declaration? Because like I recognize classes and methods and all that kind of stuff, but like declaring the interface.
Well, okay. So sure. Actually, wait a minute. Let me. Come on, complete. Okay. My computer is just being slow. I don't know why it's so slow. Okay, so here is an interface, right? The way an interface looks is instead of a class, right, we have public interface mylist, right? And an interface is just a blueprint for something that we would like to build. So it doesn't have a constructor. It has methods, but the methods don't have implementation. They just have their signature. They have their return types and their argument types. Okay, and that's all there is. All right. The following program is supposed to implement an array list. It has errors. Identify the lines which must be changed to fix the program. Fill in the 0 box if the line with comment option 0 needs fixing. And so on. There are 4 errors. So I'm sorry about this text. This text I should have seen. So what happened is, right, I had I had this problem, and I copied an old quiz, and I edited it, and I didn't notice that I said there were 4 at the end. There are 3. And I realized that that's why everybody stayed so long, is because they were all sitting there trying to figure out how there could be 4 when there actually weren't 4. And that means that everybody got something wrong, I guess. But there is a curve, so I fix it with the curve. But my apologies for messing with your heads. I didn't do it intentionally. So look, it's important for you to, one of the, I talked to you last time about thinking like a scientist, right? And I said that you should recognize that all your opinions about politics are wrong. I mean, they're guaranteed to be wrong. I mean, even as obvious as they look, right? They're wrong because you know so little about the system, and you only feel confident that you're right because you know so little. But there's another thing that happens. You assume that because I stand in front of the room and that I sound smart and I have lots of answers, that I can't make mistakes. And it's just not true. You shouldn't trust something just because I say it. You shouldn't trust anything just because any of your professors say it. You should go and check it, right? And the same thing goes for your textbook. I have found so many errors in textbooks. I mean, they're all over the place. So don't trust anything, right? You want to, if you can help it, right? At some level, you have to trust something. But if you can check something, check it, right? If I say something that sounds wrong, don't just sit there and say, sit there and be quiet and say, he must be right because he's the professor. I won't say anything because I'll sound stupid if I question it. Don't do that. Don't do that. That's not going to help you in this class, and that's not going to help you in life, right? You've got to, this is America. We're supposed to feel free to question things here. I mean, I know that doesn't apply on social media. If you question anything, you're a hater. But here in this class, we can question things. Okay. All right. So what are the errors here? Let's take a look at this. And this is kind of, there's some things that are kind of tricky. So line 0, it's just a declaration. It's fine, right? Now 87, or I'm sorry, line 1 is actually a problem. You can't see it by just looking at line 1, however, but it's a thing we have talked about. So we'll come back to that. By the way, let's just go and look ahead, right, at our answers. We got 1, 3, and 7. Those are the 3 things that are wrong. So line 1 is going to be wrong, and we'll see what that is once we get down here, right? So we look at our grow method, and how does our grow method work? It works by multiplying the length of our current physical array by 1.3. Now, if I initially allocate my array at size 0, what's going to happen when I call this grow method? I'm going to allocate a new method of size 0. So this is not going to work. So because of an error in line 1, this program will not work correctly. Okay. Line 2, there's nothing wrong with line 2. I just, you know, picked something that was innocent. It's just completely ordinary for loop. Line 3, I reversed data and new data. I just flipped them around. So this way, the code, even if it did allocate more memory, like it was supposed to, it doesn't use it, right? Because I did the assignment backwards, right? You see that? Yes. All right. I need to hear your heads rattling, right? Okay. All right. Line 4, again, perfectly innocent. Line 5, perfectly innocent. And they're so short, there almost can't be anything wrong with them, right? Line 6, I'm doing the correct thing. I'm assigning the data to the logical size. It should all be good. But again, that 0 initial length is going to bite me here. If I have a 0 initial length, this will also fail. So I probably 10 would have been nice, right? If I'd done that, that would have been life. I would not have had so many regrets in life. Okay. 7. Who sees the problem with 7? JJ. Nope. The problem is I'm using the wrong length. I'm using the physical length instead of the logical size. And because of this, right, even if I've got an array with nothing in it, I'm still going to print a 0 there, like there is a 0 at the beginning of the array. So it's a confusion about physical and logical size there. Does it all make sense? Yes. Name. Van? Van? Yeah, okay. I remember when I see you that I have trouble saying your name. Okay, Van. Okay, yes. What's the question? Yeah, so line 7, the problem is a confusion between physical and logical size. So what we're doing, right, is we have an array list. And the concept of the array list is you should only, as far as the user of the array list goes, right, they shouldn't be able to see that there's data inside that thing that they haven't put there, right? If they haven't called the add method to put data in there, it shouldn't be there. What happens in this method, though, is I'm not using the logical. If I'd use the logical size, then this would work, right? But in the way it's written is even if there's nothing in the array, it's going to append that 0 because it's looking at data.length. So it's the wrong thing to use for the toString method, right? You need the logical size because that's what you're trying to show is the things that are in the logical size of the array. Right? If I instantiate a new array and I print it out and it tells you I have one element and it's 0, that isn't correct. It should just be empty brackets, right? And this won't give you empty brackets. Make sense? All right. Yes, Scott. It is effectively an array list. What did I call it? I called it my list impl. It's our implementation of an array list like thing, and it says it in the above.
Where do you implement it as array list instead of array list?
No. So this is following the examples we've done in the class where we make something that is like an array list, but is simpler because the actual list interface is mind-bogglingly huge, right? We could spend the whole class just listing the methods on that class. Right, on that interface, sorry. So
I was thinking of looking at it as a regular array, and I did find one as an error because I was thinking put an array to size.
the following program is supposed to implement an array list. Okay. All right. And I mean, even if that didn't clue you in, right? The presence of logical size and the 1.3 and all that stuff should have been, this is exactly like lecture, right? Okay. All right, and that's it for the quiz. Yes, is it Isaac? Okay. Isn't line 4 also an error? Yeah, okay, so there is a potential error there in that get does not enforce the limits. But like we said in class, we're not enforcing that yet. I wanted to say you could put an assert there, but then you wouldn't be enforcing it if the asserts were off, right? We're gonna come up with a way to enforce that later. But that you're right. You're right that if you're making something like this for people to use, it would be good to tell them if they made an error on this line. Did you mark this as an error? All right. Well, my guess is if this is the kind of mistake, the kind of thing you mark incorrectly, that your grades are good. All right. We can talk about it if that makes a difference for your grade at the end of the class. All right. Okay. Any other questions? All right. Now I could go back over the other two quizzes, and I will if you want me to, but I have something you might like better. I have last year's first test. Would you like to see that? Now you can be guaranteed, right, that I'm going to switch everything around, but this is not a class on memorization. Oh, I can send it to you, I guess. But I mean, you're going to see this again in the video, if nothing else, right? All right, so let's take a look. Let's see what I put in here. I don't actually even 100% remember what I put in here. All right, so we have a my array list. The student turned in an implementation of an array list. Their instructions were to create an initially empty array that users can append to. They were told that they should not need to allocate new memory with every addition. Okay, so and I guess this is a what is the output question. All right. So what is the output going to put? So I have ml.get1 and ml.size, and I'm sorry, get0, get1, and size. My coloring is a bit off here, and then I'm going to look and see what I get. And so when I make these answer keys, I've got this thing I can do here. I can put compute in, and what my little system will do is it will save the program, compile it, run it, and get the output and make sure that the answer is somewhere in that list. That way, I know that the code I give you compiles and runs and it's not messed up and that the answer is really the answer. And I didn't like just somehow make a mistake. So this way I don't have to trust myself to be perfect. Okay, so let's look at the way this class is implemented. Now, the thing that jumps out at me is this line right here. Okay, private int logical size equal 1. Now, every implementation we've done of array lists, and we've done it like at least 2 or 3 times by now. What have we initialized logical size with? 0. So this looks suspicious. Okay. All right. So then we've got a size method which returns the logical size. So when I instantiate this class and I ask for the size, it's going to be 1, right? So that's something that's got to be concerning. All right, now the data is set to 10. This is familiar. Okay. And then we have a grow method. And if the logical size is greater than data.length, I think I meant to put data greater than or equal to. But I guess it doesn't matter for this example because it compiled and ran. Anyway, so if it says that, then it returns. Otherwise, it does this same dance where we allocate a new array, we copy everything into it, and then we assign the old array with the new array. Okay, so that's what we've got so far. We've got a get method that just gets the data. We've got a set method that just sets the data. We've got an add method that works in the traditional way. It calls logical size plus plus equal val, and it doesn't even bother to call the grow method. So the grow method is not going to happen. And then I've got a main method. And inside my main method, first I instantiate my class, then I add 3. So I've got 10. I got space for 10 initially there. So the lack of a grow method isn't going to hurt me. But what's going to happen is I'm going to stick that number 3 in what array element? Will it be 0? Chris, 1. It will stick it in 1. Okay, because I initialized logical size to 1. So when I call add, I go up here and I look at my add method, right? And it's data logical size plus plus. I know logical size is 1, therefore data 1 is getting that 3. Now what's in data 0? 0, right? Because that's what the initialization does. Okay, so now I'm going to print this out. So ml.get0 is going to print what? 0. And ml.get1 is going to print print what? 3. And what's the size going to be? 2. Right? Because I initialized the size to 1 and then I incremented it. Does that all make sense? Yes. Because okay, so the question is, why does ML get 1 return 3? Because we talked about where the data went. Because logical size was initialized to 1, when I called add, it went in data element 1. Right? So this became data 1 equals 3. And so now when I do a get, right, I'm doing data 1, and that's going to be a 3. All right, make sense? You can do this. All you have to do, you go through these things line by line, and you look up what each thing does. Now, if you just sort of stare at it from 5,000 feet, and you say, this looks like it's going to give me a 1, 1, 1, that's probably not going to work out. You have to go line by line through this thing and see what each line of code is doing, right? Okay. And I always put things in there that like people, for people to attract people who just have no idea what's going on. Right? Okay. Okay. So my next question is a list of true falses, right? And so here they are. So the array list whose size method returns 10 uses the same storage as an array with length 10. Well, this is not necessarily true, right? Because we know that the logical and physical size might be different. An array list add method only sometimes allocates more physical space. Sure, it only sometimes does, right? Sometimes it's okay with the space it's got. The length of an array cannot, of an array list cannot be changed. This is just false. Array list integer is a valid Java type. It is. Array list string is a valid Java type. It is. Array list int is a valid Java type. It is not, right? We cannot put primitive types into those angle brackets. Those have to be objects, right? Drew. Oh, well, so you're looking at my YAML file, which is, I have a Python script which reads my YAML file and converts it to a thing called LaTeX, and then LaTeX compiles it. And LaTeX doesn't like to display angle brackets unless you put them in $signs. It's a weird markup thing. You have to just somehow squint your eyes and look past my markup. Okay. All right. The toString method of an array list looks something like 1, 2, 3. Sure. The toString method of an int array looks something like 1, 2, 3. No. What does it look like? Say that again. Oh, well, it has, no, it's something like the letter O, a square bracket, and then the hexadecimal location of the object in memory. It's something of that nature. It's probably not exactly it, but the ending of it's the hexadecimal location of the object in memory. It's screwed up. It's why one of the reasons why we have to write these toString methods is because they identify each line's function in the Java language. So this is the similar thing to what we've seen in our quiz 3, right? We've got line 0, which is a class declaration. We've got it's almost the same code. It's almost the exact same quiz, but yeah, yeah. I just copied it apparently. It's yeah. There's yeah. So that's you've already seen this. Identify the primitive types. This is always good for fun, right? We know there are 8 primitive types. You absolutely should memorize that. You absolutely should be able to list the primitive types. If somebody walks up to you while you're in McDonald's and says, what are the primitive types in Java? You should be able to rattle off all 8 of them. Okay. Random reporter asks you that question. You should know. String is not a primitive type. Void is not a primitive type. Tuple isn't even in Java. Medium isn't a primitive type. I mean, you should just know these things. List is not a primitive type. Anything with square brackets on it is not a primitive type, right? Comment on the following code. All right, so let's see. What do I got? What have I got? What are the kind of comments? Okay, so the comments you can make is constructor, missing instance of check, unnecessary code, cast, missing cast, valid code, field declaration, override of method from base class. And okay, so you know what? I could talk you through this, but we're running low on time. Let me see what else is here. Oh, here's various implementations of the equals method, right? Because the problem with the equals method is that one or both objects may be null, and you have to take that into account. And so this is testing to see whether you can verify that, right? Here's another array list gone wrong. It's probably the same question from the quiz. See, so here's one of the things about me. I reuse questions. I will take a quiz. I will take a question you've already seen and I've already told you the answer to, and I'll sometimes give it to you again verbatim, right? So there are people who come through this class who will see the question, same question 3 or 4 times, and they'll miss it every time, right? Don't be one of those people, right? Make sure you absolutely can do all the questions you've seen before. Okay. What is the output of the following code? So these are questions where I try to test your ability to reason through code. You have to look at it and go line by line. So we start with main, right? Then the next line we set a equal to 4. The next thing we do is we create an array B of length 1 with 4 as its 0 element. Now we call incr A on A. Now incr takes a primitive type. So what's going to be the effect of that plus plus? Nothing, right? It will do nothing. Okay, so this line here does nothing. Now we're going to call incr B. Now incr B is going to select the method that has the matching type, right? The int array. And now we're going to increment array element 0. Is that going to have an effect? Yes, right? Because we pass arrays by reference because they're objects. Okay, so what's going to happen is these are both initially 4, but this makes the array element 5. All right. And then I have a stray incr A at the end, which does nothing. This might even have been a quiz question for you already. I think so. It's going to be 4 or 5, right? All right. But that's what you need to do when you see those code questions, right? You have to walk through line by line. You have to keep track of the state. You have to follow the logic. You have to be the computer, right? And you need to be able to do that in order to write programs. You need to be able to follow code line by line and understand what it's doing. What is the output of the following code? This is just testing whether you can understand prefix and postfix operators, right? So the plus plus F, you're going to see that change. It's going to be a 6, but the minus minus on the G is a postfix operator. And so you won't see it in the print statement, right? You see that? So it should be 6, 6. All right. Gorp. Okay, so here's Gorp, right? It's one of these things where you have to name all the different pieces. And I have foo. What is foo? What is foo? Package. What is capital printer? A class. What is printf with lowercase? It is what kind of method? Static. All right. My math. What's that? Class. What is engine? Good. What is cosine? Right. Okay. And then constants is going to be a class, and pi is going to be what? What is pi going to be? It's going to be so when it's in all caps, the convention is constant. So final static constant. So it's pi. It's going to be 3.14. All right. So when it's all caps, that's usually a signal that I have a constant. All right. Any questions? All right. That's my previous exam 1. That's everything that was in it. And I can send you this, and this will give you an idea. But the point is, right, you need to understand the concepts. It's not enough to memorize. In a lot of classes, you can memorize. In history class, you can memorize. Not in this class. Okay? Yes. Wait a minute, please. The flyer code should be up to date. There should be those lines there that you can uncomment to get the other behavior. What's your name? Bennett. I'm sorry, I can't hear you. Oh, I think it was last class. Yeah, you should re-download basic graphics. Was there another question? All right. All right. Good luck on your test Monday.